Hi, it's Robert Steltman. So far, about half the registered people have arrived, so we'll give it a few minutes. Isn't that the way it always goes? Um, okay, found it. Okay, so there's the manual, but that didn't take too long, too many buttons. With different videos. A lot of my routines start with a mark. So if you use the undo button in Civil 3D, it goes back one command. Mine has a number of commands built into the routine. So when you go undo, it'll go back to the beginning. And then we have settings. If we select the settings button under general, load on startup, I've got my reactors set to 2. That just adds the reactors but doesn't fire them. Default point settings, some layers. Land desktop installed is if you have some people are still using AutoCAD. Some of the tools work with AutoCAD, so they'll set that to 0. And they use ACC points to 0 if they want to use the softest point blocks. There's things for survey to plan, some controls, piping tools, if we're importing to pipe interference, some defaults, it will actually look for polylines on these layers, 3D polylines, and it'll use a default pipe size of that. Here's our default layers for going to Excel. Service connection tags and catchment areas, what block we want to use when we're doing our catchment areas. Okay, and then save, right? Currently it's going to my current directory. If you see a save local button, it's reading it off the Civil Essentials folder. Okay, oh, and one thing in the help under getting started, tips and setting precision. We use Civil 3D to set all of our settings, precisions, for distances and stationing, for slopes, and for the number of decimal places. Okay, something to keep in mind. Okay, and finally, if you want to see some of my videos, you go to YouTube and then you select Robert Steltman. And here's last week's demo. And then there's different videos, including some advertising and HydroFlow. All my videos are, a lot of my videos, I think I have 130 on YouTube. Okay, so let's start off with our demo. So under roads, I love this routine. Create multiple profiles. It allows you to select all your alignments, what surface you want to query, the styles. So these are styles that are in our current drawing, and these are the profile styles. And we go OK, and we go pick, and there's our 2 profiles. Now I'm going to draw a profile on road 1, and we OK. And we're going to go to the end point, and we're going to pick a point. And this is where we want to start. We want to match at existing ground. And as I move my cursor around, it displays the station, elevation, and grade of my tangent. We just pick a point close by, put in an even station, and an even grade. And then we can carry on from there. And then we go O snap to the end, and we want to match at the end of the road. Okay, enter to finish. There's our K for the first curve, K for the second curve, and this is design profile. And there's our design profile. Next, we're going to do it for road 2. We pick our profile and we go OK. And so we have to match at this intersection. So I'm just going to call road 1 calculate. And there's the station for road 2, the station for road 1, the elevations match, and we go OK. Enter, OK. Enter to end, and that's a design profile. And we're done. They are dynamically linked. If you go under the admin and show, you can pick this one, and it tells you this one has a relationship to that one. And you can delete it. So if we adjust this profile, this one will adjust. You just have to select update item on the profile tools, pick this one, and it will move and stay linked to that one. Okay, so now we want to put our, we want to query all the pipes along road 1, and we want to put them on our alignment. So we're going to just say road 1, okay, and we're going to search 15 meters each side of center line. And if there are crossing pipes, then it'll show up in here and you can change them to whatever you want. But here we go, saves us some time. Now we're going to go into the pipe editor, and this gives you, here's our 3 networks. We're going to select the storm, and you can pick it from the list of all the pipes that are in there. You can go close to the alignment, assign to the alignment so it'll read it, by run name, select from drawing, by profile view, or you can even save a selection. We're just going to go from the list. We just go OK. And this editor gives us a much easier way of viewing our storm network or any network. We have some options. We can start at the top and work down. We can start at the bottom, work up. We can make sure that when it changes, we get at least 15-cent drop across the manhole. We're going to adjust the invert and hold match obverts. And we're going to make sure that the sump stays lower. We can raise and lower that. And we can show the inverts at the wall of the structure or to the center of the structure. Here's our different structures. It gives us the angle in and out so that we know what drop we want across the manhole. And then for our pipes, we can change pipe sizes. If we change this to a 900, it'll make sure none of the pipes below it are smaller than the one we just changed, or we can set all of our slopes, and maybe we want 1%, and it starts at the top and does 1% all the way down, or if we have it working the other way, it'll update it the other way. So that's the pipe editor. So we're not going to change that. What we are going to do, though, is if we want to go to an Excel spreadsheet, we're going to go Pipes to Excel. We select our spreadsheet. So this spreadsheet is included in the download under the Civil Essentials folder in the C3D example. You'll see this spreadsheet, and we go next. So here's a, So here's your standard spreadsheet. CIA, this one came from the Edmonton a number of years ago. So we're going to tell it we want storm, but there could be a number of tabs. We also want it to start populating in row 16. Row 10 has our formulas in it, and it'll copy those. And all you have to do is map your column to, or the item to the column that you want it to go to. You can have multiple, it remembers all of your columns. So if I'm going to go load settings, and it goes into Here's pipe export XML, and this one is matched to that spreadsheet. We go next, and we can again pick all of our pipes that we want, and we go export to Excel, and there's our design. So we can do our full design in here. What it will send back is the different inverts and the pipe sizes. That's what it will do. So we could change this to a 900, and is this a, no, it's not a, and you could change your invert. So when we go back to Civil 3D, we can go import to Civil 3D, and that now changes to a 900. We can also start adding catchment areas, calculate storm areas, and we go okay. We pick our pipe, and you can pick up to 5 areas, and you go enter. It highlights the first one, runoff coefficient might be 0.5, it places a block. The next one, the runoff coefficient might be 0.4. We place the block that's highlighted with that one, and we go enter, and now it's associated with it. What the routine does, put an area number, the runoff coefficient, and the area. Should the polyline change, that area will update with it. So now we want to export to Excel. Where'd my Excel? Oh, there it is. So now we go export to Excel. And the total area has been brought into the Excel spreadsheet with a weighted runoff coefficient, and now you can continue doing your design. Okay, so that's how they export. So we don't want to save that. You can also export it to PC Swim, EPA Swim, or even SSA. SSA won't allow you to do 2 areas, but we can easily do that. For both XP Swim and PC Swim and EPA Swim, they both have different requirements for what you can use in your pipe name and structures. I'm going to go, so that calculates storm areas, the same one as in there. We're going to export to EPA Swim. We go, okay, and we're going to call it that, yes. And if we go under here, shipping, no swim, EPA Swim, and we go file, open. There's the file. Oh, I'm not finished yet. I lied. We're going to use a rain gauge of Grimsby, and in the city of London, they have a way of, they want to convert C to impervious, so we can go yes. And then we can go into swim, and we can open up there. And there's our pipe network. We can pick a pipe, properties, and instead of a 900, maybe we need a 0.75. We go enter, and you go save, close, and now we can go import from PC Swim. We pick our pipe network, and so it tells us that Storm 38 was swapped from a 900 to 750. And if we go under properties, maybe we can go into properties, pipe properties. We can see now it's a 750 millimeter. Okay, so now we have some crossing pipes, and we want to make sure everything's working. So under pipe tools, we have a pipe interference, and we're going to go a detail block, and we're going to do all pipes, label pro, we don't care about the profile view, and we're going to relink networks. And what this allows us to do is categorize the different networks we have. So this is a sanitary, and we want the inverts 10 units below the grid in our profile. The storm goes here, and maybe this one goes here too. And we want that one 20 units below. And we go okay. It will also do pressure pipes. I'm going to go no. And we're going to go no to zooming to intersections. And here is at this intersection, it shows us which pipe is crossing which, and these ones intersect. So it just proves to me why I'm a programmer and not an engineer anymore. And there's our different crossings. I'm just going to go undo back, and that clears that off. Now, if we need a breakdown, I'm going to go into the pipe depth report. And what it does is Civil 3D will give you the depth at each end of the pipe, but not along it. This one will walk along. We're going to walk along 1 meter, and we're going to give it to cut it into 1 meter depth columns. We can also, we're going to calculate, make sure it gives, we want the depth of the trench. We can also have it, if we're doing a cover, we can also have it tell us if it's less than our minimum cover, put an X on the drawing. Okay, right now I'm going to do that just to show that, but typically if you wanted to have the trench volumes, you would pick the bottom. If you wanted to ignore, you also have that option of ignoring null structures. We're going to select, of course, all of our, and this takes a minute. But what it does is it gives us the depths for each pipe, and also a summary of all the pipes and all the structures. And here's, so for each pipe, it tells us the minimum, maximum depth, the length, the average depth, but also in between 3 and 4 meters, there's 4 meters of cut. It also gives us a summary for all the structures, and it summarizes for each pipe size. And I only have one type of structure here, but if you had catch basins and different structures, it would give you the breakdown for each one. If you have a rock surface, perhaps, and you need to know how much rock is coming out of your trench, I'm going to go trench volumes. We're going to compare it to this. Let's assume this is our rock surface. And we're going to have this much bedding. They're going to have this much over the pipe. Depending on the pipe size, it will make the trench that much wider. We can even draw the trench with 3D polylines. And if you want to have a trapezoidal, it will go up. Otherwise, it just does a straight up and down. And we go OK. And we'll do the storm network. And if you want to have 2 pipes in a trench, you build a surface from, you run the routine using one what am I trying to say? One network, and then you run it again against another network. And here's, I think this is going to work. No, it's in. So it tells us the from and to manholes, the material, the pipe length, the trench, and the trench backfill. What we can do is we can close this. Just go file, new. And we'll close the other one, and we can look at it a little better. Open. browse. And I think that's a CSV file. TrenchX. And finish. And there you can see it's broken it up into different pipe sizes, the length, the backfill, and how much excavation came out of it. Okay, so that would be trench volumes. Now, maybe you want to set the slope and you want to start it from here and end there. There's a new routine we did called set pipe slopes. And we're going to select from drawing the storm network. No, select from profile. And there's our pipes. We go OK. And we want 15-cent drop across all the manholes. And here it is. It ends up being 0.5. And if we go save, there you can see our network. What I should have done was raise lower. We have to adjust that. Minus 0.1. Okay, so now we've got all of our sumps in place and our slopes. Okay, so if you need to generate a 3D feature line, well, we have options. Pipe networks to 3D poly. We can do it from the inside at structure links. We can do it the top, the crown, the center, the invert. We can make a feature line or a 3D poly line. And you just select it and it creates our feature line. So that's one of the routines we have. We can also, oh, here's one. Compare our pipe to our surface. We're going to compare it to the FG. And we're going to select all of our storm. And we want to have it compare the top. And we go run. And in the bottom here, it displays, oh, here's our X's where we don't meet our 4-meter cover before. And we can actually label that depending on, and you just can put those labels wherever you want. It gives you the pipe elevation, the surface elevation, and the depth of cover. And we go enter. I'm just going to get rid of those because those just cause grief. Now, in Civil 3D, they have under pipe network, we're going to add a structure table. And we want it to be the storm, which is this table, but sometimes, so it puts all the inverts into one column. Some municipalities would like to see that broken up into a different table. We just go, okay, we pick the table. We say there's 4 columns and the inverts are in column 2. We say column 1 and we pick that. And here's where it's created a new table showing us the inverts broken up into 4 different columns. Okay, some people were looking for the pipe elevation in plan. So we're going to go with the invert. You get to pick your note label style and you pick the pipe you want. and it just puts a note style on. That's the invert. That's simple. I'll get rid of that. Okay, now we want to rename all of our manholes. I've got them going from east to west, but I want them to go be numbered along the alignment. So we're going to say this is going to be our storm, starting number 1, and we don't need a suffix. We're going to go road 1, and we're going to pick the storm network, and it's going to find all manholes, and we're going to increase by increasing stationing, and it's done. So now it's storm 1, storm 2, storm 3 and 4, and so on. We can do that with pipes as well. Now, if you need to start putting some service connections in, we're going to go place a service. And we're going to go at 2% from the top of the pipe, and we're going to go a meter above the pipe. So a gooseneck. We're going to put a label, and it's going to put in a feature line or 3D poly line, and so we're going to have it put a style in. So we pick a point on our, and then we pick a point on our sewer. And okay. And there's our feature line. And you can go along and say, oh, I need one here. And you pick that. I don't know if we can pick one on the sanitary. Yeah, we can pick one on the sanitary as well. So you can quickly put in all your service connections. Some areas require pipe deflection angles. They want to see what it is, so to make sure they're getting that. Should be in here, pipe deflection angle. Oh, here it is, add pipe deflection angle. We're going to ignore small pipes. We're going to tell it to do the storm. And what it's done is it's put in the delta for each at each manhole, what the deflection angle is. Now, we were talking about doing catch basins the other day, and this one's kind of neat. We're going to go to the FG. We're going to, we have some options. We can go from a fixed slope to the pipe or a variable slope. So let's go 2%, and it's going to go 2 meters deep, down 2%, and it's going to match the obvert. And, oh no, if the obvert is less than 0 above existing, it's going to give us a warning. We're going to pick OPSD. We can either have it break the pipe and put in a null structure if we select a pipe, or it can just have it float in the air above the pipe and not break the pipe. We're going to put in a 250 millimeter, and we're going to put in a OPSD catch basin. So we'll just go okay. So I'm going to start here. Maybe we need one here. And then I pick my, and it's put in a 2%. Pipe, we can pick a spot here and looks, no. Okay, so, well, it did put in a null structure. So if we want to change the pipe creation, we just go E, and we're not going to break that and add null structures. We're going to just change that now. And we're going to go okay. And we pick our point and we select our pipe, and it doesn't break the pipe. Okay, so then it just puts it in at 2%. We can also have, if we go E to edit, there's yet one more option. We're going to have a variable slope, and we're going to match. We're going to put in a 1 meter gooseneck above the existing obvert, and we go OK, and you pick your point, you pick your pipe, and you can see that it's put in a 39% pipe. So it'll go down to 1 meter above the obvert. Okay, so there's some catch basin placement routines with unlimited amount of possibilities. Let's see if we can get rid of some of those. Okay, so that's, oh, I should see any catch questions yet. Oh. Oh. Okay, Jeff, thanks. My second screen doesn't show. Any other question? Any questions so far? Oh, hang on. Did it change the pipe? I have a question when it brought it in. It's not, I think I manually edited. That's why it changed it. I think it did change the label style when I brought it in for PC Swim. Okay. Structure labels. Okay, so now we're going to do some profile stuff. So we want to put in inverts in bands. In Civil 3D, it always places the inverts in the directions that the network was drawn, which isn't really what we want, because sometimes it's drawn from top to bottom and it won't show up correctly on this. So what we've got is we've got place inverts in directions and bands. We haven't, we don't care about band units, relink network. We can put it in middle center. We can even have a direction adjustment. If you're not working to true north, it will give you that option and adjust it accordingly. And we can just go OK. When we go relink networks, we're going to go remove. This is going to be our SAN. Again, I think because I undid it, it didn't remember. And we're going to go 20. And OK. So it's labeled all of our inverts, middle center. Now these do have reactors on it. So this one is 177.229 at the center of the manhole. But if we were to move this manhole and we were to bring it up, this does get automatically updated. And you can see that the high side is on the right as shown in the profile. Okay, so there's that. And now we're going to show, so now we might need a drop structure in there. So if we go under pipe, we're going to create a drop structure. So if it's more than 1 meter drop, which this appears to be, then it's going to put in a drop structure. And you can see that it's got this drop structure here. This is just AutoCAD entities with some text, but there are some options. If you change your design and you want to check it again, you run the routine again, it erases the other ones and puts new ones in. And we can also do that with safety platforms. If it's more than 5 meters deep, we're going to put one in at the 1/2 meter, and this may be OPSD or whatever standard you want. We're going to include the elevations, and we go OK. And you can see we've had to add safety platforms everywhere. And safety platforms. There was some other, oh, here's a neat one. Say we want to find out where this structure is. So we're going to go zoom to parts and plan. You just have to pick that structure or and maybe the pipe it's attached to, and we go enter, and you can see that it's highlighted those two entities. And we'll remove that. Okay. So there's some profiling. Here's an interesting one. So here's our, we have two paper sheets in paper space, and this structure label has to be in both. So what I'm going to do is I'm going to go into sheet 1, and under pipe tools, Pipe X duplicate structure labels. What it's going to do is we're going to pick a point in here, and it's going to find all the structure labels in this drawing, and we're going to go OK. And it's duplicated all the structure labels. So now I'm going to go to model space, and I'm going to put this structure label over to here. Now, when I go into model space over here, we can say this one is in that viewport, and this one is not showing at all. And if we go into sheet 2, again, we can see just the one label in here. Just what it does is it does viewport layer freeze on anything that it doesn't want on the original ones, and then keeps the other ones in your viewable space. So just a quick routine. It doesn't take a lot to do those duplicate, but cares anytime you can do things in one step instead of 6, it's a time saver. Now, some of our municipalities are requiring the data in a GIS format from pipes. So what we're going to do is we're going to add object data to pipes. And we're going to start with our ID 1, and we're going to draw them in 2D. And again, we have a library, and here's our pipes. And it allows us to take all the information from Civil 3D and put it into object data onto the entities. So we just go OK. Our project ID is 1, 2, 3, 4. And I'm just going to go all. You can do an SSX. And what it's done is it's created 2D lines with object data. So if we go edit object data and you select this, you can see all that information has been added onto it that we wanted. And now you can do a map export and export that data to a shapefile. There is a process, and it should be in the help file, or there's a, yeah, there, I believe it's in the help file. Okay, so that's how you would do that. I'm going to draw an offset pipeline. So under water mains, we're going to pick this alignment, and we're going to go 4 meters. No, I lied. That's not what I wanted at all. Offset. We pick our alignment. I want to just have an offset from there for 10 meters. And we want to do, no, even that's not going to work. I will get it right yet. Offset from here, 15 meters. And if we want to do a stakeout of our storm network, we're going to go under Survey, Layout Tools, Manholes and Pipes on an Offset Polyline. And we're going to go every 15 meters. We just go OK. We're going to pick the storm network. And we pick our alignment. And we pick our offset polyline. And it puts on a number of points that we can stake out. So every 15 meters, it's put on a point. And it's also put on a point on the manhole and a second point so they can line it up. A little more confusing than it needs to be, but there's a lot of information on there. Okay, it might be something. There are a number of stakeout tools if we need to. Oh, what's happening? Oh, sure. This never happens. Oh, it's done. Okay, phew. Okay, so now we have that. Add object data, offset, rename. And I'll just show you a few water main routines, pipes. So we're going to put in a water main 4 meters to the left of center line. So that just puts in a 2D polyline. And maybe we have to go around an elbow. And we say we want to make it concentric to that. And PE multiple. And we have to just join those two. Okay, so there's one that goes around. And now we want to have it offset from our original ground profile. So we go vertical offset from profile. Pick our water main and plan. And we want 1.8 meters of cover. So that creates a 3D feature line. And now we're going to pick this. Oh, we have to. I'm going to just project this. We're going to have it go over here. And we're going to place two things on. We're going to project parts in profile. Enter. I'm going to show it as a crossing pipe. Huh. Pipe properties network. Well, that didn't work. So anyways, under water mains, if we have a pipe crossing along here, we will be able to put in a vertical deflection underneath it. Okay, so there's some options. Now we're just going to go polyline to water main. We pick our polyline and we're going to create it on there. We pick our profile view. And here's what we're going to do. We're going to go PVC and we'll pick some pipe size and we'll use our vertical. And that places the pipes onto the water main onto the profile view. And now what we want to do is put in some hydrants and pick our water main in plan, pick our profile. Okay. And what we have to do is just tell it to use a T, some sort of valve. I don't know, put something in there. And I'm going to have it add a fire hydrant. And we want 50-meter spacing. We want it to have a fire hydrant right at the first lot line, and we want it 2 meters off the water main. And there's our valve, our hydrant, and our spacing. And I think that's it. That took 55 minutes. Hopefully you got some value out of that. I will be sending all attendees a quick questionnaire on what they thought, what they would like to see, and if they learned anything from this. Just a quick thanks to everybody for showing up, and stay safe.